This video is about residual. Residual is the distance between each point on a scatter plot and the line of best fit. And the line of best fit is also called your least squared regression line or your regression line. Okay? Alright. Residual is calculated as your observed value minus your predicted value. Your observed value is the original y value from your question. So if you're given a table in the question, the original y values in the table, those are your observed value. Now your predicted value is called your y hat. And your y hat, those are values that you have to calculate. Okay? So when you get your regression line, which is your line of best fit, then wherever your whatever your x values are from your original question, you'll put those values in the regression line where x is, and whatever you get, those are your predicted y values, your y hat values. Okay? Now, so let's do an example for this thing to make a little bit more sense. Okay? Alright. So here it says the table shows the temperature of a fish tank during an experiment. Write the appropriate linear equation for the given situation and use the equation to predict the temperature at the 7th hour. Okay? Now in situations like this, guys, you're going to use your calculators to do this. Now the values at the top, those are your x values. Even though it did not say x, these are actually your x values. Okay? And then the values at the bottom, those are your y values. Okay? Even though it did not say y. There are instances when your table will be given to you in a vertical way. Okay, so the ones at the front, the data at the front, those will always be your x values, and the data in the second column, those will always be your y values. Okay, so bear that in mind. Alright, so let's look at this one. So we have our calculator here. And so we hit start. And enter. We have some data in the calculator, so we go ahead and clear those. Then we put in these data now. So it is 0, 1, 2, 3, 4, 5. All those x values go in L1. Then I go over to L2 and I put my y values. 82, 80, 78, 76, 74, 72. Okay? Then I hit start again. I go to calc. I come down to lin reg. And I come down to calculate. And the calculator is showing me y equals ax plus b. This is the slope. This is the same as your slope-intercept form. Y equals mx plus b. Okay? So where a is, that is my slope. So that is y equals negative 2x plus my b value, which is 82. This is the appropriate linear equation that the question asks us to find. This is the same as your line of best fit. Okay? Or your regression line. Good. Now the next part of the question says we should predict the temperature at the 7th hour. Now it said hour, so that is a time. So that's an x value. So in this line of best fit, your regression line, where x is, you're going to put 7 instead. So this would be y equals negative 2x, which is 7, plus 82. And let's find out what that is. Okay? So negative 2 times 7 equals negative 14 plus your 82, and that is 68. Okay? So it asks us for the temperature, so that would be 68 degrees Fahrenheit. Okay? Alright. Let's go to another example. Example 2. This time they gave us an incomplete table. Alright? And they gave us the linear function. They gave us the line of best fit. They gave us this. We don't need to find it. Okay? Now it's saying complete the table. Now remember that your predicted value, those you calculate when you put your original x values in your line of best fit. Okay? So here it is 0.5. I want you all to see. It's 0.5 times your first x value, which is 5, and that is 2.5. Okay, let's use a different color marker for this. Alright, and then 0.5 times your next x value, which is 10, and that is 5. Alright, and then 0.5 times your next x value, which is 15, that is 7.5, and then 0.5 times your next x value, which is 20, and that is 10. Okay, now to get your residual, remember residual is y, which is your original y value, minus y hat, which is your predicted value. So here it would be 3 minus 2.5, and let's use a different color marker for this so you all can see exactly what's happening. So 3 minus 2.5, that is 0.5. Alright, and then 4 minus, so let's actually do it here. 3 minus 2.5, that is 0.5. And then 4 minus 5, and that would give us negative 1. And then 9 minus 7.5, and that would equal to 1.5. And then 7 minus 10, and that would equal to negative 3. Okay? Now, so that is how we complete the table here. The next part, it asks us to draw a residual plot. Now, the residual plot is drawn by using your original x values. So let's do it here. So here's your residual plot. On your x-axis, you're going to have your original x values. Okay, so I have 5, 10, 15, 20. That's my x value. Now on your y-axis, you're going to label that residual. That is why it's called a residual plot. So this part is your residual. Okay, and the thing is called residual plot. That's why you use the residual values for your y values. Okay, so this now would be 1, 2, and I could call this 3, negative 1, negative 2, negative 3. Okay, alright, so here we're plotting 5 against 0.5. So it is 5 against 0.5. 0.5 would be between 0 and 1. So that would be about here. Okay? Then the next point we're plotting 10 against negative 1. So 10 against negative 1 would be about here. So it's a different color marker because this thing. Okay. Okay. So 10 against negative 1 would be about here. Alright? And then we're going at 15 against 1.5. So 15 against 1.5. 1.5 would be between 1 and 2. So that would be maybe about here. Just estimating. And then finally, 20 against negative 3. 20 against negative 3 would be probably somewhere about down here. Okay, and that is our residual plot. Now the final part of the question asks us, does the residual plot suggest linear relationship? Okay, to tell if it suggests linear relationship, your residual plot has to look random. You can't see any pattern in this thing. For sure, you can't see any parabolic shape, any circular thing or half circular thing. No, because it said linear has to be straight line. Now, but how do you identify if it's linear? The plot's got to be random, no pattern to it. Okay, so yes, it suggests a linear relationship. Okay, and then the next part says we should explain. Well, our explanation is because the plot is random. Okay, and that's it. Have a great day.